All right. Um, good day, good evening to everybody that is just joining. It's going to be it's a pretty late one. Um, I know for most of my folks out there, it's pretty much late, but I think I still want to do it anyways, right? I still want to go ahead to just quickly do something. So if you're just joining the stream, welcome. Waris, what's up? How are you? Yeah, good to see you. Thank you for joining. Welcome to the stream. If you're just seeing this or just like joining the live stream for the very first time, you're welcome. This is me. My name is Oluwashitemi, and I sometimes do this on Fridays and Saturdays where we just talk about different things, most importantly, JavaScript. Anything around JavaScript is always exciting and interesting for me. So, yeah, you're welcome. You're welcome. Abdul Qadri, Bosse, how are you? It's so nice to see all of you once more. Thank you so much. So, what do we want to talk about today? I think I think the title of the stream should be advanced working with functions. So it's going to be a very so we are getting, if you notice now, like we're getting into like the deeper stuff inside JavaScript, right? It's just deeper. I think some new persons might join the stream today. Maybe some of the persons that just subscribed to my channel today because I spoke at a particular event later on. So if you're just joining and you're watching for the very first time, thank you so much for doing that. Um, you can always check all of the previous videos that I've done where I talked about JavaScript. Most importantly, I talked about like the basic JavaScript things that you need to know, right? Just basic stuff. So all of the videos are well explanatory, and they were done following javascript.info, right? Javascript.info, right? So I'm going to share my screen briefly, right? And also, if you have other interesting ideas that you want me to talk about, right, you can always, tell me about them, and I can find a way to teach them. So I'm just going to quickly share my screen, and so what do we expect, right? What do we expect from what do we expect from this particular topic that we are looking at? Here we have advanced working with functions, right? And it's another very, very interesting thing in JavaScript. Most importantly, it talks about, advanced usage of functions, right? Things like recursion, understanding your stack, understanding rest and spread parameters, variable scoping, then the idea of closures, right? Then what is the behavior of VAR? Then the global object, which is like your windows in your browsers, and which is global this in the Node.js context, and the function object, right? And it talks about how to use the new function syntax. Then also we have the scheduling API, which is the set timeout and the set intervals, and decorators and forwarding with call and apply. I think some of my friends and students here might know what call and apply means, right? I think it's another very interesting thing in JavaScript. Also, we have function binding and arrow function revisited. So all of these things are pretty much very interesting areas of JavaScript. So let's just quickly get into like the recursion side of things, and let's see if we can do something with the recursion. I'm not sure how much time we have, but I want to see if we can at least do something very fast with So basically, what is recursion? I think recursion in programming just means that, like, right, we keep calling the function, right, again and again and again, right? Just like you keep repeating the calling of a function. Most importantly, right, like a very powerful example is like factorial. If you look at factorial, right, if you look at the factorial function, do they have any factorial function here? No, we don't. So let's try to see if we can quickly write the factorial function, and we can quickly. So I'm just going to cd into my favorite side of things. I think it should be under streaming. Do I have something under streaming? It should be JavaScript, and it should be JavaScript live stream, right? And we should be able to touch. Let's just say recursion, right? .js, and we can then open our VS Code, right? And instantly that brought up our VS Code. So the last time we talked about the stream, right? We talked about numbers and strings, and iterables. So today I'm just going to quickly like talk about um recursion, right? What do we have with recursion, right? So what exactly is recursion, right? If we are to look at recursion, what is the major particular thing that we have in recursion? Again, it's just the ability of a function to always call itself as many times as possible, right? The ability of a function to always try to recall itself as many times as possible. So we have the function keyword, right? And we can call it function, say factorial, right? And so when you have factorial, it takes a particular value. Copilot is already helping me there. And so it means that we are just going to do, let's do this here. Let's use this comment first before we write any code. If you look at 5 factorial, what is 5 factorial? Anybody? What do you think 5 factorial is going to be? So 5 factorial naturally, right, gives us something like what? It gives us something around 5 multiplied by what? 4 factorial. And so if we want to achieve something that looks like this now, so we'll probably say if 5 is here, right, you want the result of the function to be what? You want the result of the function to be what? 5 multiplied by 4 factorial. Does this make sense to us? Does this make sense? Right? That is, 5 factorial is what? 5 multiplied by what? The factorial of 4. And so you understand that there is what? There is a recalling of this factorial function that is here again, right? The next time. So it means that if it goes into the next what? The next level will be what? 5 multiplied by what? 4 multiplied by what? Multiplied by what? Multiply by 3 factorial, right? And so if we want to achieve that, then we need to be able to what? Make this 5 to be what? N, right? We can make 5 to be n, right? And we can say that what? This 4 is now going to be what? What is, if we want to get 4 in terms of 5 using 5, if we want to get value 4 using 5, then it will be what? 5 minus 1, right? Which is going to be what? N minus what? 1, right? And this will automatically work. Now, the problem here is that we will get to a situation where what? Where we will run down to what? 5 multiplied by 4 multiplied by what? Multiplied by 3 multiplied by what? 2, and multiply by what? Multiply by 1. And what is 1 factorial? Right? What is 1 factorial? 1 factorial is what? 1, right? So what we need to do is that 1 is our exit strategy, right? And we can say that if n is what? Equals to what? Equals to what? To 1, then we want to do what? We want to do what? Return what? 1. So it means that what? This is the exit strategy of what? This factorial. This is the exit strategy so that we don't run into an infinite loop, right? Because it will keep going until we get to what? Like minus, so it will then do minus 5 factorial. It will keep going, minus 6 factorial. But that's not what we want. We want 1 to be what? Our exit strategy. And that is that here. And if we run this with Quokka, right? And for those who don't know what Quokka is a tool that we use to run our JavaScript. And to make this work, then I need to call what? A console.log 5 factorial, right? And we get our result. Does this make sense? That is, this is us writing the factorial function in a recursive what? In a recursive way. Or in a recursive way. If we want to write this factorial without using recursion, if we need to write this factorial without using recursion, can anybody maybe tell us how we can go about it? To write a factorial function without what? Being using the recursive approach. So it would have been what? A factorial 2, right? To be what? Let's just say function factorial 2, right? Open the bracket, which is what? Our value, right? N. And we want to do something that looks like this. Now, what this means is like you want to do a loop, right? You want to do a what? So we want to say something like what? Let result equals to what? Okay, so let result equals to 1, and we want to create what? A loop. We want to create a loop from where? From that n down to what? From n down to what? 1, right? So that's like a that is a what? A loop, right? So we can use the for loop, right? We can do a for loop that goes downward, right? Let high, let's say, since we know the value of n before, and we can just use instead of using let again, we'll just probably say let's say high is what? I is equals to n. Okay, it's still the same thing. I probably don't even need to do this. I is equals to n anyways. And we can say that high is what? Greater than 1, right? And high decrement, right? High decrement, and we have the what? The loop. And so here, if we console.log what? If we console.log high here, high is supposed to grant us what? The values of what? So let's do this here. Factorial. Okay, let's do a console.log factorial 2 5. So you'll notice that now it is going what? It is going it is going downward, right? 5 4 3 2, and I think we still need 1 here, because this loop is not equals to, let's just say it is greater than 0, and we get the 1 there. And we can then do what? The rest, right, is equals to what? Rest multiply by what? High. That is, multiply 5 by what? Multiply 5. So the first thing here is going to be what? Multiply 1, right, which is rest, by what? By 5. And it will save the result inside the rest, and it will go back again. So you can see that 5 times 1 is 5. Then it goes back and say the value of I has changed to what? 4. Then we'll say what? 5 multiplied by 4, and it gives us what? 20. And it goes again, 20 multiplied by 3, which is what? 60. 60 multiplied by 2 is 120, and 120 multiplied by 1 is what? 120. And so we can return what? We can return what? Rest here. And this also works. So this is a version here with the what? With the for loop. A version here with the for loop, right? Do we understand? And I think we can also write this with what? A while loop. Can we write this with a while loop? Right? We can say that what? While what? N is less than, while n is what? Less than, is it, let's say while n is equals to, let's say it should be greater than 0, right? While n is greater or equals to 0, like greater or equals to 0, then we want to do a what? A res multiply by this. And if I console.log the value of what? If we console.log something here, why is the last value 0? Then it's supposed to be 1. Yeah, it's supposed to be 1, right? And here the last result is what? 120. So you can see with the while loop, right? And then we can also use the do while as well. We can also use the do while to write all of this, and we can say a do, right? So it will first do what? Res equals to what? Res multiplied by what? N, right? And we want to decrease n, right? N decrease, and we want to have what? A while, right? A while condition, and it all comes together. So this is a way of writing a factorial without using recursion, right? Or writing this factorial without using recursion. But that's not the goal of why we're here. The goal of why we're here is understanding what what um what recursion means, right? What recursion means. So what is recursion again? Recursion is the ability of what? Functions, right, to always what? Call themselves. And one thing that is important is there must be an exit strategy for the recursion, so that we don't run into an endless what? An endless what? Loop, right there. So the same thing goes for what? When we have a power function here, right? This is a power function, right? This is 2 raised to the power 2, 2 raised to the power 3. So the idea here is what? You're multiplying 2 by what? By 2 ones. I think this is 2 times 1, 2 times 2, right? And this is 2. You're multiplying 2 3 times. You're multiplying 2 4 times, like that. So we could write another what? Ordinary function that carries out that same process for us. Or we can decide to leverage what? This recursive what? Version. We can decide to leverage the recursive version. Again, you can see this exit strategy here, right? You can see this exit strategy here. So it is again, if we were to implement that, right, I think I can move this terminal to let's just say move this terminal to better still. How do I even move this whole thing to is it only terminal that we can move into this? I thought it's the whole thing that we can move. Okay. I thought it's the whole thing that we can move into the editor version here. All right. So if we want to write a power function, right, where you want to have a power by what? A power that powers 4, comma what? 4, right? So if you want to write this now using recursion, right, using recursion, how can we carry out this out? So we want to have what? A function power, right? And you want to do what? It takes two things, right? The base, right? And the what? The exponential, right? The base and the exponential, right? We do something that looks like this. Now, the thing is, again, what is the action that is happening? What is the action that is happening? In this kind of function, what's the action that is happening? So it's going to be what? 2. So for this situation here, we have 4 times what? Times 1, right? Which is equals to what? 4. And then we also have what? 4 times what? What do we have again? We have what? The result, which is going to be 4 multiplied by what? 2, which is what? 4 times 2 is what? No, what am I saying? Yeah, it should be this. 4 times 2 is 8, right? And we have, now it's supposed to be 8 multiplied by what? 8 multiplied by 8 multiplied by 4. Sorry, what am I doing? Am I doing the right thing? No, how does power work again? Can somebody remind me how power works? I think I'm mixing power up. If we say 4 raised to power 4, what does that mean? 4 raised to the power of 4. What does that mean? 4 raised to the power of 4 is multiplying 4, right? Multiplying 4 in 4 places, right? Multiplying 4 by 4, right? 4 times. So we have the first time, which is 4 multiplied by what? 4, right? And then we do another 4 plus what? Plus 4 multiplied by 4, right? Like that. Yes, exactly. Thank you. Plus another 4 multiplied by 4 plus another 4 multiplied by 4, right? Which is still the same thing as us saying 4 multiplied by 4 multiplied by what? Multiplied by 4 multiplied by 4, right? There. And what this means programmatically is that what? We need to return, right? We need to return how do I say this now? So definitely we are going to have our exit strategy, right? What is exit strategy? Our exit strategy will be what? What's our exit strategy here? If it gets to what? If it gets down to 1, right? If it gets down to what? 1, that is if exponential is 1. If exponential is 1, then we return back what? Our base, right? We just return what? 4, right? And else now you want to return base, which is 4, right? Multiply by what? Multiply by another what? Another what? Operation of what? Power, right? Which is what? The result of another what? 4 multiplied by exponential minus what? Minus 1. And I think that this is supposed to give us what? If we look at this now, I think it's supposed to give us what? A thing. So if we do 2 to the power of 3, 2 to the power of 3, that's supposed to give us 8, right? 2 to the power of 3 is supposed to give us 8, right? Is 4 times 4 times 4 is it 66? Is it 256? Is it 256? Let's just do node. We can do 4 raised to power 4. Yeah, it's what? 56. Right there. So basically that is recursion, right? The cool thing again is there must be what? A exit strategy. There must be exit strategy, and right here, this is the exit strategy. So the exit strategy provides a way for the function to stop running so that we don't run into infinite what? Infinite loop. But do we understand, right, how recursion works, right? Do you understand how recursion works? So this is the recursive part. You're recalling this same function that is here, and it will create a chain. So it will create a chain, right, of what? 4 times what? If exponential is if exponential is 0, I think we need to return 1. Hmm. Anything raised to power 0 is what? Yeah, anything raised to power 0 is 1. Yeah, that's true. Anything raised to the power of 0 is what? Is 1. It's the same thing though. It's the same thing because what you're just saying here is that no, I think I see what you're saying there. Hmm, I think so. Let's see. So it's supposed to be like this. Let me get what you're saying down. Yeah, I think it's correct. Yeah, I think it's correct. It's still going to be the same thing though, I think. Right? You're saying that if exponential is 1, then we return base. We return the base, right? And it will still serve the same function, right? It will still serve the same thing. Do you understand why it will still be the same thing? Because anytime you are doing 4 times 1, that will be what? 4. Anytime the member of the, well, yeah, anytime the member of the array is what? Is 1, right? The last power is 1, which is 4 times 1 will still give us 4, which will return back the base to us any day, anytime. So we understand, right, that it should still be the same thing. I think it should be the same thing. And whether you use the exponential as the exit strategy, or exponential equals to 1 as the exit strategy, or you use the other one, which is what? Exponential equals to 0 as the exit strategy. Do you understand what is? Are you able to relate with that? Hmm, that's nice. Thanks for bringing that up. Both of them are actually like the same thing there. So another thing again for us to be aware of is there is another one. We have another thing called the Fibonacci series, right? The Fibonacci series. Also, you can use recursive function to solve that as well, right? And basically that is a little bit about that. Do you understand what it is, or do you need me to explain? Mm. Also, we can use recursion in our linked list. You remember the implementation of our linked list, right? That we had. We can also use some form of recursion in our linked list. Please, can you give me a sec? Let me take this banner off the stream. Hmm. Give me a second, please. All right. So so what are the applications of recursion, right? To day-to-day code that we're going to be writing. I think how do I say this though? Do you see this line here? Can we see this line here? Can we see that line? That line says that anytime we use recursion, right, it can be rewritten with a loop, and the loop variant can be made more effective. But sometimes the rewrite is non-trivial, especially when a function uses different recursive subcalls depending on the conditions and merges their result, or when the branching is more intricate and the optimization may be unneeded and totally not worth the effort. Recursion can give a shorter code, easier to understand and support, and optimizations are not required in every place. Mostly we need a good code, and that's why it is used. So sometimes having the recursion, right? Having recursion can be like a very interesting an interesting piece of code to write, right? Because it is very short, right? It's very short. And sometimes it's easy for anybody who is new to understand that, well, the base, we're using the base again here, and we're trying to what? To create another calling of a function here. So that is that. So this is what another very good necessary thing that recursion is used for. Another good application of recursion is what? A recursive traversal, right? Imagine we have a company we have a company. The staff structure is what? Company, staff, right? You have the name of the staff and the salary, the name of the staff. Then we have what? Development, and development contains what? Sites and internal, something like this. In other words, a company has departments. Departments can be arrays of may have arrays of staff, for instance, sales, right? And or department may split into sub-departments like development and sites and internal, right? And they will still have the same the same structure. So for instance, the sites department in the future may split into site A and site B, and they potentially can be split even further. It is this That's not a picture, it's just something to have in mind. So again, what they're just trying to tell us here is a way to represent the data of a company. So here, if you look at this version here, we have company, we have sales department, we have development, and inside development we have the site, and we have the internal. And then we have a function that helps us to sum all the salaries of everybody together. And so what this would do is what? You can see that it is checking if department is an array, right? If department is not an array, then is an array, then it does the reducing based on what? It does the reducing based on what? Um, it does reducing, right? That is, if it is sales, it will reduce using array. But if it is not sales, right, it will use what? It will use object to get through to each of the member of the department. So for example, it means that if it gets to development here, we are what? We are looping through sites and we're looping through internal. So it will calculate for sites, it will calculate for internal, like that, like that, like that. So again, recursion here saves a lot of stress in terms of like compared to the way this, if you are to be finding the sums of all the salary here, right? That would have been very tedious, right? But with the help of recursion here, we're able to have one function that fits all to be able to calculate what? The recursion. So another good example of recursive structure, right, is what? The data structure, right? We have what? Text species, HTML, right? But linked list is like a major one, right? In terms of what? So in this situation now, the keeping an example of what a linked list, right? Which is what? The value and the next. So here we have an object that has what? Value, and we have what? Next. And inside next, what are we going to have? We're going to have another value, right? And another what? Another next. And inside that next, we have another thing, right? So we keep on having value and next, value and next, value and next. And that is what we refer to as what? A linked list. So this is the graphical representation of what we have, right? So this is the first thing. Let value equals to 1. Then you can now do what? List dot next equals to what? Value 2. And then you can now see that what? List dot next equals to value 3. List dot next equals to value 4. And you can end it by saying what? Link dot next 4 times, right, is what? Null. That is the last item. All right. So this is another very interesting what? Another very interesting approach of what? Of what? A place where recursion can be handy, where recursion can be handy. So here they are what? Prepending a new item, and to remove the value from the middle, right? If you want to remove something like this from the middle, right, you have to what? Locate that thing. And in the process of locating, you need to what? Do like what? Okay, check, is it this one, is it this one? And once you see that, oh, this is the one that has value of 2, then you can now break the whole thing down and what? And join. You can break and join. So again, it's another very interesting it definitely, linked list has its own problems, right? But we're just saying that we can represent what? A linked list with recursive structures, right? That ability to just quickly design a recursive structure, right? When they say recursive structure, it's just around the fact that whether it is an object or whether it's an array, right? The goal is to what? At least show a recursive behavior, right? That is, oh, the next year. So if we are going to implement a find in our linked list, or you're going to implement a what? A insert, or if anything you're going to implement, right, that that include the traversal of node, right, that might need what? In linked list, that would need like a form of recursion, right? Or you use a loop, right? You'll notice that in the linked list example I shared earlier with you guys on YouTube, for those who don't know, there is a YouTube video where I spoke and implemented what? Linked list. And if we check here, I have linked list, right? This is my code here video explanation where we talked about the implementation of what? Of linked list. Feel free to watch any one of them. So basically, I think that about recursion, right? Yeah. So you can also use recursion to what? Look at this function here. Can we implement something that looks like this using recursion? So if we want to implement the sum to using recursion, again, we need an exit strategy, right? We need an exit strategy. And this is the exit strategy, right? The if n equals to 1 is the exit strategy, right? And you're able to do something that looks like this. 1 is still missing. Is this correct? Okay, it's correct. Again, it is very, very, again, you see we are calling the functions again right there. So that's a um very interesting approach, right? Of what? Using recursion. Any questions about recursion? Any questions about recursion? Any question about recursion? All right. I mean, in the absence of none, right? I think the key takeaway here, right? I feel like the key takeaway here is to understand that recursion saves us sometimes. Anytime we are using loop to do something, right? It means that there is a form of exit strategy, right? And I think the moment you are using a loop to do something, then I think calling that function again the next time might also be a valid approach. Calling that function again the next time can also be a valid approach for us to use. And that's why I was saying that what understanding recursion helps us to bring power to the way we understand and use what functions before now, right? When you understand recursion, the ability to call a function multiple times, that you have that power means you can what do some magical what implementation or use right there. And I think that with that, you can also check the other ones, right? I think this is factorial. You can check the other ones, right? And I can call today's stream, bring today's stream to an end, right? Which is what? Mm. So again, these here, all these are examples that we can go ahead to work on, right? All these are examples of stuff that we can do. Again, here they say we should implement a linked list in reverse order. So just implement a method that can reverse a linked list, or you do a particular print list or headline. So again, recursion is the ability to recall functions multiple times to achieve a purpose. So what are we going to be talking about next Friday? Next Friday, we will talk about what? Rest and spread operators. And if we're able to move fast, we can talk about variable and scope, right? And I will be seeing you guys. Any question before I bring the whole thing to a close? Any question? Any question? Do we have any question? All right. So again, thank you for joining the stream today, right? I do appreciate you guys. And I think we should see tomorrow where I am supposed to talk about Next.js and the beautiful project that we are working on next Friday. Tomorrow is Saturday. Hopefully, I can get to stream way earlier than this. I hope to stream tomorrow 3 p.m. my time, or that's 9 p.m. the Nigerian time. And I want to stream about a new project that I will be working on from scratch, from beginning to the end, using what Next.js, right? Using the power of Next.js right there. For those who are probably new, right, you need some level of React, or you can watch my previous explanations. I also have a previous explanation on Next.js, right, that shows you how Next.js work and how to get up and running with Next.js. So again, I will be seeing you all tomorrow. Thank you for joining, and bye for now, right? Thank you.